11.1, inverses of simple quadratic and cubic functions. What we're going to do today is we're going to take a function and we're going to graph it and find its inverse. What that means is, if you take your calculator, go to your y equals on your calculator, clear everything out. In y1, put x squared. In y2, put square root of x. So it will be second x squared. Right there is a square root button. Second x squared of x. Then graph that. Here is x squared, and this is square root of x. If I were to draw a line at y equals x, right up there, those would be mirrors of each other. Now, I know on this calculator it doesn't look like they're mirrors because of the spaces here. Do you see how wide these are? And look at the spaces here, how narrow those are. So it really doesn't look like they are mirrors of each other, but they will be. Okay, so that's what we're doing today. We're going to take an equation and we're going to find its inverse. Okay? All right, let's go back to the book. I'm on page 572. Problem A. Now, problem A, I want you to write this in your Cornell notes. This is a typo. This should be 0.5 x squared. Okay, so in your book, it's just a typo. Now, notice this says restrict the domain. If it says restrict the domain to where x is greater than 0, we're only graphing in this first quadrant where x is greater than 0. So we're only graphing here. So we don't have to worry about the graph anywhere else. Okay, only in the first quadrant. If it does not say this, then we're graphing everywhere. So this says restrict the domain to where x is greater than or equal to 0. So it'll be in the first quadrant.
Wouldn't that be the top and bottom though? Because my x is still greater than 0, but it's just not 1.
It's all going to be it's all going to be in the first quadrant because there won't be any because it's a square.
Okay.
And so it'll all be positive. Okay? That's a good question though. All right, so you're going to take the original problem. This is your first step. You're going to replace f of x with y. Y equals 0.5 x squared. Now on this particular problem, I'm going to change 0.5 to a fraction because it's easier to solve if that were a fraction. So I'm going to change 0.5 to 1/2. Y equals 1/2 x squared. So the first thing I did was replace the f of x with y. I changed the decimal to a fraction. Now I'm going to switch my x and y. So I'm going to make my y an x, and I'm going to make my x a y. That's how you find inverse. Once I switched them, now I'm going to solve for y equals. I want to get y by itself. How would I get rid of the 1/2? Multiply both sides by 2. That will get rid of 1/2. So that will give me 2x equals y squared. 2x equals y squared because the 2 and the half will cancel. And then that'd be 2x equals y squared. How do I get rid of a y squared?
Square root.
Square root it. So I'm going to square root both sides. So the square root of 2x equals y. Now once I do that, then I'm going to replace the y not with f of x this time, but with f negative 1 of x. Because f negative 1 of x means the inverse of this right here. So this equation right here, the square root of 2x, is the inverse of this one right here. So when I plot these, when I graph them, they should be mirrors of each other. Okay, and this is how you do it. Put this original equation in your y1. Find me or tell me what some points are with x greater than 0 or equal to 0.
1, 2, 3.
Some points.
1,
2, 2. Give me another one. 4, 8. Which is going to be way up here somewhere. How about 0, 0? Is that one of them?
Yes.
Okay, 0, 0. So I just graphed, it's going to curve, I just graphed f of x equals 0.5x squared. Now, put in, erase that, and go to your y equals and put square root of 2x. Give me some points. 0, 0. 2, 2. 8. 4.
Yes.
8, 4. I'm guessing somewhere up here. So it looks like. Oops. Sorry. It looks like that. So if I took y equals x, this line right here, and I want you to draw that line on all your graphs. And I have rulers if you want to use them. And I folded it on that dotted line right here. Would those land on top of each other? Yes. Those are called inverses of each other. Okay, this equation right here was the inverse of my original. Questions? That's it. Now,
F of x or f negative 1x equals square root of 2x, is that your answer?
that's your answer. What I'm going to look for is this as an answer and the graph. Okay? Now the directions say use composition to check your answer. We're not doing that. So you don't have to check it. Okie dokie? Alright, next one. Your turn, number 3. Tell me what page we're on. 574. 574. Your turn, number 3. Alright, so I have f of x equals 3x squared. What did I do first? Change it to a y. Y equals 3x squared. Then what did I do?
Switch x and y.
Switch the x and the y. If you need to write these steps down, then I would do it because it's always how you find your inverse. I want to get y by itself. Divide by 3. So x over 3 equals y squared. How do I get y by itself? Square root, both sides. Square root of x over 3 equals y. What does f negative 1 of x equals?
Square root of x over 3.
Square root of x over 3. It says restrict the domain, so we're only looking at the first quadrant. So go to y equals on your calculator, put in 3x squared. I'm going to go ahead and draw my dotted line up the middle. Okay, y equals 3x squared. Give me some points. 0, 0. 1, 3. Way up there. So it's going to curve way up there. And that's enough because it went off my table. Or went off my graph. Now let's put in f of x equals square root of x over 3.
3, 1.
Okay, 0, 0, right?
Yeah.
And 3, 1. So it goes like this. Oh, I didn't go 1, 3, I went. Did everybody catch that?
You did 0.5.
I did 0.5, it should be here.
I was wondering why.
I know, me too. I was like, why is that so skinny and that's so long? There we go. Watch your graphs because this is every 2 lines is 1. Inverses of each other? Yes. They look like mirrors. Any questions on that? Alright, let's turn to page 576. Your turn number 5.
What two things do you use to find this? Like this you use to find
That and
like
the original one.
original.
Okay, on number 5, now your story problems are going to work a little bit different. So look at number 5, it says the function of a of r equals pi r squared gives the area of a circular object with, I don't know what the rest of that says, with respect to its radius r. Write the inverse function r of a to find the radius r required for area of a, then estimate the radius of the circular object that has an area of 40 centimeters. So we have a of r equals pi r squared. Now we are going to change this to just say a equals. A equals pi r squared. We're not going to switch the a and the r this time. Not on the story problems. We want to get r by itself because we are estimating the radius. So we want radius equals. So how would I get r by itself?
Divide by pi.
Divide by pi. A divided by pi equals r squared. How do I get r alone?
Square root.
Square root it. So square root of a divided by pi equals r. This is really r of a. Okay, there's my answer. Right there. Then it says estimate the radius. It has an area of 40. So where am I going to put 40?
In the A.
In the A. Square root of 40 divided by pi equals my radius. What is the square root of 40 divided by pi?
3.57.
Okay. 3 point, does it say round to anything? 3.57. I think I put 3.6, which is fine.